In this video, we're going to talk about alternating current. Alternating current is a current that is an oscillating function of time. We have various forms of alternating currents, but for the purpose of this video, we're going to consider only that which is of practical importance. That is the sinusoidal alternating current, the form that we use in our homes and industries. Okay, so that's the one that we're going to consider, sinusoidal. Now that's what we're going to consider in this video. Okay, now for example, if we have a coil of wire rotating with constant angular velocity in a magnetic field, it will develop a sinusoidal alternating current. Now, the main feature of that sinusoidal alternating current is that the direction of flow and the magnitude of current changes periodically. For example, if I have a graph like this, and this is current I, here is 0, this place is negative current, here is positive current, here is negative current, and it is moving in this direction. We will have something that will go like this. And so on. Now, here is the peak current. I naught. Here is already naught. Now, from here to here is half cycle. To here is one cycle. So it means here is period T. So from here to here, one cycle. So we call it one cycle. So that is T, period. From here also to here, another cycle, which is 2T, and so on. The same thing applies to when we have for a voltage. It will still go this way. Here is 0, here is negative V. So from here, here is peak. The peak V naught. So it's moving in this direction. So here, half cycle, another half cycle, so T. Half cycle, 2T. So here is one cycle. Okay, so now this is the sinusoidal form of current, alternating current, sinusoidal alternating potential difference. Now we know that period has a relationship, which is the number of cycles that is completed in 1 second. Okay, so the number of cycles that is completed in 1 second is given as 1 over f, because the number of cycles completed in 1 second is frequency. So the number of cycles completed in 1 second is frequency. Therefore, T is 1 over f. And because of that, we can look at the peak current. The peak current is the maximum current. You can see from there is the maximum current. The peak voltage is the maximum voltage. You can see at that peak. So we can have the peak current of the sinusoidal form as I. Let's look at I equal to I naught, which is the peak, sine 2 pi ft, or you can say sine omega t. This is because omega is equal to 2 pi f. So for voltage is given as the peak voltage sine 2 pi ft. So moving on, we have what we call root mean square value of alternating current. So this is what we use, current root mean square value. Now, having that, we can define it as the value of the steady current which when flowing through the same resistor produces heat at the same rate as the mean rate produced by the alternating current. Now we can prove that using this equation, that I RMS, that's root mean squared, is equal to the peak current over root 2. In the same way, the value of root mean square of voltage is also giving us the peak voltage over the square root of 2. For the applications of alternating current, the first one is that we use it in manufacturing household appliances like radio receivers, television, etc. Second application is that we use it in manufacturing transformers. Third application is that we use it in AC motor, that's for converting electrical energy into mechanical energy. The fourth application is that we use it for transmission of electrical energy over long distances. Okay, let's look at this example. It says a voltage source delivers 200 volts root mean square to a 250 watt hot wire. Calculate the peak voltage, resistance of the hot wire, the root mean squared value of the electric current, the peak value of the current, the power factor. Now from here, for us to solve, we know that the root mean squared of the voltage given to us is 200 volts. Now the power given to us is 250 watt. For us to calculate the first one, which says peak voltage, for us to calculate the peak voltage, we know that V root mean squared is giving us V naught over root 2. This is the peak voltage, remember. So we can say where V naught equals peak voltage. So for us to find this, we make it subject of the formula. V naught will be cross multiply V root mean squared times root 2. So which is 200 times root 2. If we calculate that, we get 280.9 volts. So we need to understand that peak voltage is the maximum voltage that can be produced by an AC current. Okay, the second one we should find is the resistance R. Now resistance is given as the voltage, root mean square voltage squared, that's V squared over power. Now having known that, we know that we can say recall that power on its own is V squared over R. That's where we got this. Okay, so because of that, R is equal to, from here our V is 200, so we say 200 squared over the power given to us is 250 over 250. Can use calculator. If we have that, we'll get 160 ohm. The third one we are to get is the root mean square value of the electric current. So they want us to find root mean squared of the current, and remember I is V, we use root mean squared since it's root mean squared, V over R, from Ohm's law that says that V is equal to IR. So if we make I subject of the formula, it becomes V over R. That's how we got this. So since it's root mean squared over this. So if we fix value, I root mean squared becomes the root mean square V they give to us 200 over the R that we just got is 160. So if we divide that, 0 cancels 0, 20 over 16 will give us 1.25 ampere. Okay, let's see if the next one, IV, is the peak value of the current. That's I naught, peak value I naught, And remember that I naught is equal to I root mean squared times root 2. This is because we said that I root mean squared is equal to I naught over root 2. So if we make I naught subject of the formula, you cross multiply. So having that, we say I naught is equal to I root mean square is 1.25. So we see 1.25 times root 2. Okay, so we'll have that it is equal to, if we press calculator, we'll get 1.77 ampere. So let me turn. The last question is the power factor. So the power factor, let's call it power factor. So the power factor is given as peak power over peak root mean squared. So remember that peak root mean power root mean squared, power root mean squared is given as current root mean squared times voltage root mean squared. So because of that, for us to get that, we'll say this is given as 1.25 times this one is 200. If we multiply that out, we'll get 250. So because of that, power factor, let's use P, power factor is now equal to P peak, that's power peak, is now 250. They give to us in the question, that's this over 250 that we just got, 250, which is 1. This cancel it, so which is 1. Now power factor is the ratio of power dissipated in the device, the circuit device, to the power of the root mean square value of the voltage and current. So that is it. Please remember to subscribe to my channel if you have not. Thank you.